And after that we'll identify that if the light is on the single direction, then we saw that the compound is chiral, and if the light is in this way, different ways, so you'll see that the given compound is asymmetrical or having achirality. Okay. After that, chiral compound converting this light into two motion. It is like a clockwise manner and in anti-clockwise manner. Okay, so when it converting into clockwise manner, then that is known as levorotatory. And if in anti-clockwise, then it is dextrorotatory. Okay, levo and dextrorotatory. So L and D represent those levo and dextro form. This L and this D. So what you needs to know, you only needs to identify that the given compound is L type of sugar or D type of sugar. Okay, I'll give you some example. Wait a second. Say this image. Okay, so
Is it okay to make it bigger?
yeah, wait. Mm, yeah, is not visible.
Yeah, yes, it is.
Okay, so see, in this case, they'll ask you that first thing that you needs to know the structure of glucose. How many carbons glucose having? What is the formula for glucose?
CH2OH.
No,
Oh, yes,
glucose.
that's so good. C2H6O. Oh,
Okay.
C6H12. Sorry, I said O12. Oh my God. C6H.
Okay. So this is the formula for glucose. Now, how we identify that the given glucose is D glucose or L glucose? So see, this one. We proceed from this carbon, okay? The second number carbon from the lower side and fifth number carbon from the upper side, okay? And if in this case OH is in the right side, so it will be D glucose. And if OH is in the left side, it is L glucose. Understood what is D glucose and what is L glucose. Now you tell me, what kind of organic compounds these are. Like they are anomers, epimers, diastereomers, enantiomers.
I think here they would be epimers, right?
Not
Uh,
diastereomers.
but it only changes in one spot, isn't that?
Yeah. So is there diastereomer also, or only epimers?
Or no, epimers are a type of diastereomer.
Yes, all epimers are diastereomers, so they are also diastereomer and epimers both. Okay,
Yeah.
I will give you one more example. Okay. Now identify which is D and which is L in this case. So first example is of xylose. Okay, xylose. So in this case, OH. is this compound D xylose or L xylose?
Can you make it a little bigger, please? Sorry, it's hard for me to see.
This is, I think, the last.
Is it hard to make it bigger?
Yeah, it's too
Okay.
hard. Okay.
Okay.
Yeah.
Yeah.
Now, okay. So the first structure is xylose. This one.
Yeah. Okay. So what do you want me to do? Oh, classify each of the
D or
stages.
L type.
Oh, okay. Yeah. This would be D, right?
Yeah. First is D. Then ribose.
Ribose is L,
Hmm.
right? Is it ribose? Actually, no. Wait. Hold on.
OH on which direction?
Uh, it's is it L? What is it? Wait. Sorry. No.
Ribose.
Ribose. Oh, wait. Um, all of them are HOH. So,
So that's why I'm telling you now, like how we are going to proceed. We check only this
uh,
carbon, this one, in each structure. We doesn't care like what is the exact, what is structure, how many carbons are there. Doesn't mean. We only check the last second carbon, always. Okay.
oh, okay.
And firstly, last second carbon, then
Last second carbon. Okay.
and then second. OH is in the right side. So in that case, it will be L or D, D type. If OH is in the left hand side, so it is L type configuration. Okay, you can remember left by L, L and L, similar in left. Okay, do you understand?
Wait. Sorry, just give me one moment to write. Left. Um, uh, okay. Right is D. L. Oh yeah, L. Like L
Yeah, L
is the
represent
same as
left.
left. Yeah.
Okay, now tell me the first one is xylosis.
Mm, OH on the left. Oh no, this would be D, right?
Yeah, second one.
D.
Second one.
D, right?
Yeah, third,
Also D.
fourth.
L.
L. Okay, so now do you understand like how D and L configuration will be?
Yeah.
Okay. Any question? Any other questions?
No.
No?
Oh, sorry. From the homework, yeah.
Yeah.
Uh, um, for number one, it says Fisher projections
Yeah.
shown below. Were we supposed to make the Fisher projection ourselves?
Yes. In this case, there is like Some statements are given. So on the basis of these statements, we need to prepare two structures. Okay. Let's suppose the first molecule. Okay, the question, the molecule first we are going to draw. Okay, in molecule first, there is a CHO on the top. OH. Okay, so firstly, CHO on the top. How we will draw that? CHO on the top. Okay, that will. Then CH2OH at the bottom.
Yeah.
Okay. Then OH on right at C2. So which is C2? Let's suppose it is a type of C2 and C3 are there and CHO and CH2OH. Okay, so that means there can be four or more than that carbon present. OH on right at C2. So this is the first molecule, then second. OH is on right hand side and at C2 and C3 both. Is this okay?
Yeah.
You understand? And if
Are
OH,
you assigning? Oh, sorry.
yeah.
Are you assigning priority?
No, I'm not assigning priority. C in this case, there is given C2 and C3. So, majorly in case we are putting the top one as a first rank, then second, then it is the third carbon.
Oh, okay.
Will be fourth carbon.
Sorry.
Okay. After that, we will form a molecule 2. So, how molecule 2 will form? Can you try molecule 2?
Yeah.
Okay.
Okay.
Any issue?
Wait, sorry, sorry, I'm still doing it, ma'am. Hold
Oh,
on. Okay. Yeah, I'm done now. It's like the same as just flipped, like the OH and H are flipped. That's all, I think. So, yeah.
exact same structure.
Mm, uh, on carbons 2 and 3, the OH and H are flipped to both side, the other side, right?
Is this correct?
Yeah, I think so.
Yes. Now, you need to define the relationship between these two molecules.
Yeah, so they differ in two chiral centers, right? So then they would be diastereomers.
How? See, first mirror image. Is there showing any sort of mirror image?
Oh, sorry, yeah, there's a mirror image.
They are having mirror image.
Uh, yes.
Confirm.
Huh?
Are you sure? Like they are having mirror images?
I don't know. You asked me about the other one.
Yeah.
I said,
I guess they are mirror images or not.
uh, let me think again, like
Yeah.
twice about it.
Okay.
Um, let's see. Mm, Yes, they are.
Great. So if the compound having mirror images, then those are
Enantiomers.
enantiomers. Now, after that, any doubt?
Wait, I have a question. So when solving this problem, like, should the setup be that you have a plane and you would first try to see if they're a mirror image or not? If they are a mirror image, then it would be clear and it would be an enantiomer. If not, then it would be something else, right?
Yes.
But I mean, if it's a mirror image, it would actually be pretty obvious.
Yes.
But
Like, what's issue in this case?
sorry, I was just thinking because I remember like you said or you told me that diastereomer like you could have some chiral centers change, but not all of them. If all of them change, then they're enantiomers, right?
Yeah.
I remember you taught me that. So I was just like considering that like if there's two chiral centers that change, could it be a diastereomer? That's what I was thinking.
But yes, yes. But firstly, we will check mirror images. Okay, mirror
Okay.
images is our priority. If there is a mirror
Okay.
image, then it is an enantiomer. If not, then it can be diastereomer. It can be apimers or anything like that. Okay.
Okay.
Mhm.
For anomers, do they have to be in a chain, like a cyclic ring?
For anomers,
Yeah, do anomers have to be in a cyclic ring
yes.
with oxygen? Oh, okay.
And
So
anomers
they,
are generally represented in a structure form. Okay.
okay,
Yes.
yeah.
Also, that the given organic compound is a type of anomer.
Oh, okay. So because in these questions, they don't really have any structure. There's no structures. Glucose, like there is oxygen in the molecule. So I was just wondering, how would I know if it's
Ox-
anomer or not?
yes, oxygen can be, but oxygen in the ring form, not like
Oh, okay, okay, okay,
open
okay.
oxygen. Okay.
Oh, that's different. Okay, yeah. And then enantiomers, do they have to have in terms of the configuration, do they have to be the complete opposite?
Yeah, like if
Okay,
first molecule having R configuration, then the second is having S for sure. And
okay.
all chiral carbon share like switch their configuration.
So the complete configuration changes?
Yeah, for
So
each
just
chiral
like
carbon. The
for each chiral
configuration.
carbon. Okay.
Yeah. Let's suppose if in the molecule 1 and 2, if the second number carbon is R, while in case of molecule 2, the second number carbon is S in case of an issue. See, there is a question also, the fourth number question.
Yeah, I'm looking
Which
at that one.
which of the
Yeah.
following pair represent an enantiomer? So how will deal that?
Oh, sorry, are you asking? Yeah,
Yeah, I'm asking you.
so oh, enantiomer. I think it's B, right?
D,
B
B. Yes.
for
B.
each chiral carbon. Yeah.
Yeah. Mm, what do you think about C?
I was either thinking of like between B or C. It could be between B or C.
Yes.
Uh, R S S R S S. Oh, right. I don't think it can be R S, right? Because that would mean it's a diastereomer, right?
Which one? B?
No, no, C.
C. Why not C? C can be also possibility and B can also. So, in
Yeah.
case of enantiomer, all the like configuration will exactly opposite to each other. So C is like a more into a completely opposite because in case of B, we are having R and S and R. So we doesn't like
Oh.
see them as is they are in continuous manner or not. So B can also, but C is the correct one.
Yeah, what I was saying, sorry, I think I like misspoke. Like wasn't able to say what I wanted to say. It was like I was saying like for part for sorry for answer B, it could be a diastereomer, right? Because not everything
Hmm.
is right.
Yeah, yeah.
Okay.
And for what for like for A?
I think that could also be right.
Yeah.
Diastereomer.
Yes. Good.
Um,
Then after that, any
I wanted to check like number. Hold on. Let's see. So D glucose and L glucose. Are we already covered that? Never mind. So the optically inactive one for number seven.
okay,
did we talk
which
about the meso
yeah, yeah,
compound?
sure. Which one of the
That came
following
up there.
optical?
Number seven. Did we talk about the meso
Sure, sure,
compound?
sure. The following is optically inactive despite. Okay. So meso compounds. Meso compound in this case, you need to know that in case of meso compound, there are two possibility needed or two condition needed. Okay, so the first is that in meso compound there should be plane of symmetry present,
Yeah, meso. Yeah, I think you told me that. Yeah, I remember.
and the second one is there must be center of symmetry present. Okay, in that case, the compound will be meso compound. Let's suppose I'm having the example. Mm. And one more thing that this compound also having chirality. Chirality means it having chiral carbons. So how many chiral carbon in this case in this example?
How many chiral carbons? Two,
Hmm.
right?
Yeah, two chiral carbon. But
Yeah.
instead of chiral carbon, this is optically inactive. Why?
Optically and because there's nothing that's changed at all, right? Is that way? Because
Yes,
there's no,
yes.
yeah.
There is no any change in optical activity. So, whenever any chiral carbon are present in any compound, then the compound is optically active compound. While not, then it is optically inactive compound. Why it is optically inactive? Because there is a plane of symmetry and center of symmetry in this organic compound. Okay. Do you see any sort of plane in this case? Any center of symmetry in this organic compound? Are you able to see that?
Yeah, I am able to. Sorry, can you ask again?
Okay. What is plane of symmetry and what is center of symmetry?
Plane of symmetry is like if you were to like get a mirror image, right? Like you have a plane
If
and you
I'm
want to
putting any plane in any organic compound, then there must be mirror images of each other. Let's suppose I'm
yeah.
having this compound. Let's suppose I'm having this compound and I'm putting a plane in this compound like this, in this manner. Okay, from above side and like this. Okay, so is both these compounds are same, like the A part and B part are same? Is they are mirror images of each other if I am applying a plane in between them?
Um, is there a mirror image? No.
How? If I'm applying plane in between them.
Oh, uh, yeah,
Yes.
yes.
So this is known as plane of symmetry. Okay. And now the next term, that is center of symmetry. How we see the center of symmetry. So let's suppose I'm having the same organic compound and one OH on this direction and another OH on this direction. Okay. Now, did you see any sort of center of symmetry here? How we'll check center of symmetry? We are putting a center point, okay, and from the center point we see the distance of molecules. So let's suppose from above side and below side both are carbon carbon, from diagonally both carbon carbon, from this side both OH and OH. So there is a center of symmetry present. Okay, so that's how we'll check center of symmetry and plane of symmetry. So meso compounds are those compounds which contain plane of symmetry and center of symmetry. Okay, do you
Mm.
understand?
So what did you write there? Closely.
Which
Constant.
here?
Con
Here is
yeah.
COS. COS means center of symmetry present.
Oh,
Okay,
so it's one chiral carbon, right?
where
No, sorry, I'm saying like the center of symmetry would just be one chiral carbon. Carbon.
a center of symmetry identify for a whole compound, for a complete molecule.
Mm-hmm. What I
Okay.
meant is like in the whole compound, like it's the center one, center carbon or chiral carbon, or
Mm,
no?
no, we doesn't need a chiral carbon for this one. We only need a center of a particular compound.
Oh,
Okay, this is a tartaric acid.
so is this an achiral compound?
This one, which one?
The compound
First
you just drew.
or second? This is not carbon in this case. Is this middle one? This is not a carbon.
Oh.
This
Oh
is,
yeah, that's not a carbon,
I'm
yeah.
putting a center in this whole compound to identify that is there any
Oh,
center
okay.
of symmetry present or not.
Oh, okay. Sorry, I was like confusing with the other bridgehead structures we drew. There was like something. Oh no, never mind.
No, no, no,
Sorry.
no. These are completely opposite. I'm just explaining you that how we will put plane of symmetry and center of symmetry in given any organic compound. Okay, so now
Yeah.
you are going to put center of symmetry and plane of symmetry in tartaric acid. So what do you think is tartaric acid having plane of symmetry and center of symmetry?
Tantoic tonic acid. Which one is that one? Tartar.
The first one, first question,
Oh.
the pink one.
What was your question again?
Is the compound having plane of symmetry or center of symmetry?
I think plain.
Yes, it is having plane of symmetry. So that's how we identify meso compound. Do you understand what is meso compounds?
So is this achiral? Achiral?
Yes.
Okay. How would you
Achiral.
define achiral?
Yes, yes, yes. That's what I'm
How would
going
you
to do.
define that? Achiral. Like there's no stereocenters? Is that what it is? Like in a molecule?
See, so firstly you need to know what is chiral. What is chiral? What?
Um,
Yeah.
I think it's like the possibility of a stereocenter. or something? Or it's like where there's a stereocenter so that, if you changed something on that carbon, it'll like change the molecule or something like that.
Chiral center or chiral stereo center, that means that a carbon which is having all four different groups. Okay.
Yeah.
So if any carbon compound which is having different groups, all groups needs to be different in case of chiral. Let's suppose I'm having a carbon, and it is having four groups, and all groups are different: fluorine, chlorine, bromine, and iodine. Okay, so is this carbon is chiral carbon? Yes, it is chiral. Okay, do you understand what is chiral?
Four different groups, yeah.
After four different groups, you can also write that chiral carbons are optically active.
Yeah.
Okay, then the next term coming, that is achiral. Achiral means achiral means they doesn't have all four different groups. There is a two group can be similar, or like three group can be similar. Okay, so when the compound is not chiral, then it will definitely be achiral. Okay, and achiral compounds. Okay, and achiral compounds are optically inactive. Any issue up to now? What is chiral and achiral?
Um, no.
No. So see, can I say that chiral compound needs to be optically active, and achiral means optically inactive compound?
Yeah.
Okay. So now see meso compound. Is meso compound optically active or inactive?
Meso compound is inactive.
Inactive. Is they are having a chiral carbon?
No.
See again.
No.
How?
Wait, I thought we were just sorry. It's not
Yeah.
achiral.
That is
Oh,
the
oh, wait.
that's why I'm like explaining you in detail chiral and achiral, because meso compounds having chiral, but it is not optically active. That's why meso compound is a term.
Oh, okay. Yeah, we
Okay.
talked about that. Yeah,
Yeah.
we just talked about that.
Yes. Okay.
Okay.
Now do you understand what is meso compound? What is the question related to meso compound?
Um, it's let me see. It says
A
which of the
seventh
following.
question. Which of the following is optically in?
Yeah.
Okay. Do you understand now? Seventh question.
So it is meso, right?
Yeah.
Okay, I put that as the answer because I knew it wouldn't be an enantiomer diastereomer
Okay. No issue.
because those will have chiral
Mhm.
carbons, right?
Yeah.
Oh,
But
wait, wait,
we're
no, the
like
meso has chiral. Sorry, meso has chiral. I keep forgetting.
meso, enantiomer, diastereomer, epimers, all of them are having chiral carbons. But enantiomer,
I'm
diastereomer, and
sorry, Rebecca.
epimers are always optically active. Okay.
Yeah,
Yes, only meso compound is optically inactive.
because there's no
Yeah,
plane of symmetry, right?
because
Oh, sorry, there is a plane of symmetry, but
yeah,
not there's no center.
yes, there is no
Okay.
center.
So meso compounds will always be chiral,
Achiral.
but didn't you
Like
say they're chiral
achiral,
or
but chirality will be there. Like there is two terms. See, chiral carbon is present in meso compound, but the whole compound is achiral.
yeah, that's what I was getting confused about because I remember you
Yeah.
told me they were achiral and then chiral, so I wasn't sure.
So the all complete organic compound is achiral, but it has chiral carbon. See, in question first tartaric acid, the first carbon, which is highlighted in green color, it has all four groups attached to it is different. Do you understand?
Yeah, that part is chiral or the different
Yes. Yes,
groups,
but
right?
the whole compound is achiral because there is a plane of symmetry.
Oh, because it had yeah, because of the planar symmetry.
Mhm.
Okay, I see. Um, and then for number, I think was it number 10? Wait, one second.
Number 10. Which pair below are diastereomers? Okay, so check diastereomers.
I put A. Let me check the answer key. No, it's actually C. Okay, C.
See, the B and the D is not for obvious. Do you have any doubt in B and D option in case of 10th question number?
No,
No. B and D are
enantiomers.
enantiomer, absolutely.
Yeah.
But D and L glyceraldehyde. So what is D and L?
Uh, D and L.
Yeah.
It differs in hold on. The H we talked about this, right? HOH.
Hmm. H and OH.
So it just differs in one chiral center. Chiral carbon, right? Center.
Yes. At which position?
Second to last.
Yeah. So see, what is D-glyceraldehyde? D-glyceraldehyde is this one. Is this form D or L?
That's gonna be uh let's see. It's gonna be D. No, sorry, not D. Yeah, it's gonna be D. Right?
And
And the other one, oh,
other one L. So this D-glyceraldehyde and this is L-glyceraldehyde. Okay. Now see what is the difference in between them. Is there diastereomer?
I don't think so. No,
What they are in exactly?
enantiomer, right?
Enantiomers. So
Yeah.
the
Oh, so
answer will
then,
be C. Okay. And you can directly
oh,
give answer to C because C in case of C there is two carbon. The first is R and like first and second is RR. And in case of mirror image of that RR, one will be remain same and only one chiral carbon will change. Okay, so whenever only one or less than complete molecule changes configuration, then in that case it will be a diastereomer. Do you remember
uh,
that when the all configuration in a given compound will change, then in that case the organic compound is enantiomer. If there
Yeah,
is
if all of
one
them
or
are
two changes, then it will be diastereomer.
stereomer.
Okay.
Oh, yeah. Um, and then let's see. Oh, for numbers, if molecule has two, number six, if a molecule has two chiral centers and no plane of symmetry, so that won't be meso, right? Or I don't, sorry, no, never mind. I don't know what I'm saying.
Which one? Which question?
For
Sixth.
for number six, yeah, would it be
A
an enantiomer?
molecule has two chiral centers and no plane of symmetry. Okay.
Oh, no, that's not an enantiomer, sorry.
Sorry. The total number of stereoisomers possible is okay. So you can leave this question because in this case you need to calculate the total number of stereoisomers. Stereoisomers are like stereoisomers can be geometrical and can be optical isomers. Okay, so which type of organic compound shows stereo, which type of geometrical, which type of organic compound shows uh, optical isomers. Okay, so on the basis of that you can identify stereoisomers. You don't need to calculate this one. Okay, you can leave the sixth question.
Okay.
Yeah.
Um, and also I think I had a question about so the last for from the last class that we had,
Yeah, which
I
one?
had a question about a problem we did. Like I tried to redo the problems that we covered, like redo them.
Sure, which
And I had
one?
from like the last session that we had or
Um,
yesterday because we have a session every day. I don't know. Sorry, it's
yeah,
I
yeah.
should just yesterday. Yeah, the
Which
I had a
question?
question.
Before this?
I don't know if we labeled it with like a question number exactly.
Okay. Okay, so tell me whenever it needs to stop.
Wait. Sorry, sorry.
Is anything from this?
This one. Oh, cis and trans. No, wait, can you go up more? Actually, no, 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 keep
Yeah.
going. Keep going. No, keep going down.
No?
Oh, this, I think this is from a different session, or is this, no, never mind. Uh,
You can tell me the question.
how do is there a way I can send it to Dhananjay sir so that he can give
Yeah,
it
yeah,
to you?
sure. Yeah.
Yeah, that's easier. Okay.
Did you share?
Yeah, I sent them to him.
Okay. Okay, okay. So this is the question. I think we did this question in.
Wait, sorry, I don't, maybe I didn't, I think I took pictures of our last class. I don't know if I copied down all the notes. Like maybe I'm doing the questions from like, not yesterday, the day before.
Yes, this is the
Confusing the
this
material
is the
together.
question, no? You're asking.
Yeah. Um, yeah, so I had like a question about how like to assign priority here because based on the answer like
Okay, so you need
oxygen
to identify that how I'll give them priority. Hmm?
or maybe I wrote the priority down wrong. I think.
Okay,
Hold on. Is
just
nitrogen I wrote nitrogen as one instead of you have three, right? I think maybe I
yeah.
like wrote it down incorrectly. 1 second. Sorry, give me 1 second. I'll just correct that. Maybe that's why I was confused. Oxygen
Mm,
will like always
yeah.
come first between nitrogen, right?
Yes.
And then sulfur. Okay, that makes more sense. Um, I think that was all I had. Wait, let me double check.
Hmm.
Oh, oh, yeah. I think yeah. I don't think these were the notes from yesterday, right?
Mhm. This is the day before yesterday, I
That
think.
was the day before, yeah. Think I wrote yesterday's notes like on my tablet, not my notebook, so I got them confused.
No issue.
Yeah.
And there is one more question, huh? Right.
Yeah.
Okay.
That was also like prioritize how this was from a bridgehead structure.
Yeah. So how
Yeah.
will prioritize that? Wait a second.
Like how did you set that part of the bridgehead structure up? Like I'm having trouble visualizing it.
Okay, so this is the structure.
Yeah.
Second one.
The second part, yeah.
Okay. So you, I think, okay, so you're going right. Okay, so what sort of issue you are facing? Like how I prioritized it? See, in first case, there is chlorine and bromine. So obviously, chlorine is bromine and is in higher atomic side. So they are getting first priority. After that, in case of second, after that, in between second and third, second is getting more priority as compared to third, just because of the NH2 group, nitrogen, and obviously COOH group.
It
What sort of
wasn't like
issue you are
my issue
facing?
wasn't prioritizing. It was like, how did you
Yes.
even draw the structure from the bridgehead
Okay,
structure?
okay,
Does that make
okay,
sense? Yeah.
okay. So see the second number carbon.
Hmm.
Are you able to see that in a question? The bridge compound.
Yeah.
Okay. So on dash side, which group present?
Wait, which one is the second carbon?
See
Oh, yeah.
this one.
Mm-hmm.
Hmm? And fourth group, that is hydrogen, that is present on dash position. Okay.
Why is it dash now? Oh, dash. Sorry, not wedge. I'm
Yeah,
confusing
it
them.
is presented in the question only.
Yeah.
Okay. Now see on upper side, uh, I'm using highlighter in the pink shade. Okay. Now you understand from the highlight. Here is this one. Do you understand the upper part of the question, main question, upper part, which is having
Mm-hmm.
carbon and then bromine and chlorine attached to upper side.
Mm-hmm.
Okay, so I represent the second one in this manner that the carbon here and bromine and chlorine attached to carbon. Okay,
Mm.
Then on lower side, there is two path. Let's suppose this is the path first and this is the path second. Okay. I'm like draw as it is these path as it is, like this is the first path in the second here and this is the second path. Okay, I draw exact same carbon and the species which is directly attached to carbon. So here is carbon and I draw here is carbon. Then again one carbon. Then I again attach one carbon. Okay. In the path second, there is a carbon. See, here I draw a carbon. Then at carbon here, which is having NH2 and COH. So I also draw NH2 and COH. Done.
Okay. My also, and I have another question. Like, you know how when you have like all of these groups right around the carbon, like how do you know which group to choose? I don't know if that makes sense. Like, I don't
You
know
can
how.
arrange. Okay, okay. So you can arrange them as you see them. Okay, like as you imagine them. If I
Yeah.
yes, if I attach these groups in a different way, then there is also a possibility that we are getting correct answer because we need to imaginate the structures majorly.
Yeah.
The only thing that you need to imagine these structure. You only needs to know that a fourth group is on a wedge side because it is designed as wedge side. Oh, sorry, dash, dash position. Okay, and upper side means upper side you needs to draw that, and if there is lower side these two carbons, so you needs to draw at lower side only. I have some questions. Okay, wait a second. Then maybe you. I'm sharing my screen. Wait a second. Okay. So is this are these questions visible to you?
Yeah.
Yes. So I'll share this PDF with you also. And in this PDF, there is organic molecules are drawn. Okay. So you can
Mm-hmm.
identify. Okay. So let's do the third question. Give the answer for third question. So you'll understand more about how the structure looks. You're going to imagine more. Do you have any doubt from the previous question? Firstly, we'll discuss that if possible.
No, I was just wondering, like, when you draw, like,
Yeah.
the
Yeah.
Fisher, not Fish, is that the Fisher?
No, that is not Fisher.
That's not Fisher, sorry, Wedge and
Yeah.
Dash.
Yeah.
Well, Fisher's different. Yeah, so, like, I was just wondering, in terms of the groups that you associated
Mm-hmm.
with the carbon, like, in the middle, the center carbon, like, how did you pull them out from that head structure itself? So I think
Mm-hmm.
I had some, like, trouble visualizing the bridge head structure.
Okay, no
Maybe it was a
issue.
structural, yeah, like a
Mhm.
the visual thing for me, more so.
So see, there is a
Yeah.
similar question. That is fourth question. Fourth question. In fourth question, here is a chiral carbon. Okay, and in this case, how you represent that? See, like this, these two carbon and carbon, and one on bridgehead position carbon, and there is a chlorine. So can I represent this as like this?
Yeah.
And now you can give numbers. Is now it is easy or not? Can you draw?
Yeah.
Yeah. You
Oh, no,
just
no, that's not easy to number, no, right? Because it's not easy to number because everything except for CL, everything is just C, C, C. So you
no.
don't know
I
the
mean to
difference.
say like easy to represent like this how it
Oh,
bonds. So
wait,
for
sorry, can you
numbering,
say
you
that
needs to
again?
know that is it chiral or not. Okay, first we will do these questions. Then you will understand.
Okay.
Okay, so Let's try the fourth question. Fourth question. Hmm?
Wait, sorry, did you ask me something? I'm so sorry. I don't know. I think I missed
Yeah,
something.
I'm asking you fourth question.
Oh, like to do it? Sorry.
Yeah.
I'm so sorry. I got like disconnected. Sorry. Like,
Okay.
yeah, I had to log back in from my tablet. My laptop lost like charge. Um, sorry. Let me just. Sorry, I have to do this problem. Um, okay. Is the molecule shown below chiral or achiral? Okay.
Okay, so what is chiral?
There's like chiral in terms of like the whole molecule, right?
No, yeah,
Oh,
yeah.
four
Counts.
different four different groups, four different
Yeah,
groups.
yeah, good. So the fourth compound, we'll check the fourth first. In fourth question is like they are having all different groups.
In the fourth question, um, I don't depends on the wait, let me see.
First, you'll check that is fourth group having chiral carbon or not.
The fourth, which one?
Fourth question.
Yeah, the for question four, I don't know what carbon to look at, but I'm assuming it's achiral, this one.
Is it achiral? How?
Uh, but cause I don't know what carbon like to look at. Which one do I look at? Is
You
it the
can.
one that's connected to Cl
Yes.
or okay? Um,
So, is all the atoms or molecules attached to Cl is they are in like is all the items are attached to this position are same or not?
no. Oh, like sorry, no, they are.
We'll check chiral and achiral. How I will check chiral and achiral. Chiral
No,
needs
they are.
to, yeah.
Sorry. No, I was gonna answer your question. Like, I think the groups are all they're not all different, if that makes sense.
In case of chiral, they needs to be all different. But in case of achiral,
Yeah.
the groups can be seen. Okay. So is there firstly we will check chiral carbon. So is there any chiral carbon over there? Any carbon which is having all four groups different in the case of fourth question.
Mm,
Do we have any carbon
no,
which is
no, 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 no.
so there is no any chiral carbon. So the whole molecule is achiral.
Achiral.
Okay, now let's see the third question.
Oh, okay. You want me to do the third question?
Yeah. Is the third question chiral
Okay.
or achiral? And if achiral, then why? And chiral, then why?
Okay. Um, like chiral, achiral. Uh,
This is so easy that
I
chiral
think so. Yes,
having
yes,
all
yes,
different
yes,
groups.
yes, yes. Yeah, yeah, yeah. Set, yes.
So is it chiral?
Yeah, chiral.
Check again.
Wait, oh, sir, maybe I like rushed too much. No, I don't think it is.
Chiral means all groups attached to the carbon needs to be same. Oh, sorry, needs to be different. And achiral means same.
Yeah, then it's not. It's not chiral.
Yeah.
It's not chiral. Sorry, I wasn't looking
You put down
carefully.
this
Yeah, it's
thing that
like very
chiral is
easy. Yeah.
having all four groups are different.
Okay.
Yeah. Okay, now we'll do the first and second question.
Okay.
Okay, so tell me
The first question, um, is it chiral or achiral? I think achiral.
how.
Mm,
Okay, let's suppose we are talking about this carbon. Okay, this carbon is
yeah,
having OH and there is two different bonds and there is one hydrogen attached to here. Okay,
yeah.
there is
Oh
one
yeah.
more. Yes. So OH and hydrogen is different.
Sure.
Then here is CH2 while here is CH and OH. So all the four groups are different. So this is a chiral.
Yeah.
Done. Now let's see the second question.
Here,
Do second
there's a
question by
plane
yourself.
of there's a plane of symmetry in number one, right?
Yeah.
So that's an I guess like that means that it was chiral. I don't know why I thought it was achiral. Okay,
Yeah.
anyways.
The first one, no?
Yeah. It's okay,
Yes,
yeah, it's
yes,
okay.
yes,
I don't know
yes.
why I thought it was
Yeah,
achiral.
you're right, you're right. Yes, there is a
Huh?
chiral carbon are there, but chiral carbon are there, but the whole molecule they are asking us. Okay, so the whole molecule is achiral. Why? See, we discuss a compound. Do you remember that?
Yeah.
Meso compound.
Meso compound, yeah.
What is meso compound?
There's a plane of symmetry, right? But it's
Yeah.
not
Yes,
optically active or something like that.
yes, plane of symmetry there, and it is optically inactive. So this is also
Inactive.
example of meso compound.
Meso, that's what I was thinking. Yeah,
Yeah,
because the
yeah.
plane of symmetry,
You
that's what
are
I was
right.
thinking.
This is achiral. Good. Not, it is not a chiral, it is achiral. Now, second one.
Hmm.
Now solve the second one.
Is the molecule shown chiral or achiral? Mm.
How we deal with these type of question?
We have to see if the groups surrounding the carbon, center carbon, are four
Yeah.
or not, right?
So
Yeah.
what do we do firstly that we just assume all these three carbon as one carbon.
Oh,
Okay.
okay.
I also told you earlier this concept, if you remember.
Yeah,
It's
you
one
did.
question
Yeah.
related to this. So
Yeah,
I'm
you did.
saying CS3 over here and COOOH. So what is COOOH? What type of functional group it is?
COOH. Is it carboxylic acid?
No, in carboxylic acid there is only two oxygen.
Oh, COOOH?
Yeah,
Oh,
per
I'm
acid.
not sure.
COOH is also known as per acid. Sorry. Okay. Now see this question, this organic compound. This one. Is the organic compound chiral or achiral?
Um, it's chiral or sorry, give me one second. Okay. No, it's not.
No, it's not. Why?
Because not all four groups are different.
Yeah, there is two same hydrogens are attached to this
Yeah.
carbon. Good. Okay. So this is also achiral. Now we will move further. We do first, second, third, fourth, and now it comes fifth and sixth question. Okay. Let's do the fifth and sixth question. See the fifth question.
Mm-hmm.
Any doubt in fifth question? Okay, let's see. This carbon we will check first. This one. Okay.
Mm-hmm.
In this carbon, both there is two CS3 groups attached. So this is chiral or achiral?
Achiral.
Achiral. While let's suppose this one, this carbon. So this carbon having all groups are different. See, in the one direction it is O, and on right hand side there is a carbon which is having CS3. On the left side it is CH. Okay.
Mm-hmm.
This carbon is chiral. So the whole compound is chiral. You can do one more thing if you need to identify chiral and achiral. You note down this thing that chiral carbons. If we sometimes if we are not able to understand that the given compound is chiral or not, we can directly use by the help of POS and COS. POS and COS needs to be absent. Do you understand what is POS and COS?
Yeah. P O
Plane
S. Oh, plane of symmetry and then carbon of symmetry.
center of symmetry and plane of
Oh,
symmetry.
oh, okay. Sorry, I forgot.
Yeah.
Uh, Plane of symmetry and then center of symmetry, right? Okay.
Yes. Okay. So, do we apply POS on the fifth question? Is there any possibility that a plane of symmetry is present over here?
No.
No. So it is a chiral molecule. Okay.
Yeah.
Okay.
That's what
Now,
I was doing, I think, with the first one, like when it was Nizo, I tried to apply this.
yeah.
Yeah.
Yes, you are applying that. Yeah. Okay. Now, sixth one.
Mhm. Which of the following terms best describes the pair of enantiomers shown compounds shown below? Enantiomers, diastereomers, or the same compound? Um, okay, let me see. CH3, H. Oh, CH.
So how we will like
Oh,
start this one?
wait, sorry.
The one structure is in like 3D form and one is in Fisher form. So
Yeah.
firstly, we need both of these structure in a same manner. Okay. So firstly, we'll convert the 3D structure into Fisher. Okay. Can you do that?
Yeah, I've done that.
Okay. So tell me on left hand side, which group will come,
NH2,
and right hand side?
CO2H,
Very good. And upper side?
CH3.
And here is hydrogen. Okay. So now, is they are similar? Is they showing similar sort of things?
I mean, it's
Can
kind
we
of similar,
identify?
yeah.
Can we identify enantiomers and diastereomers in this case? Like
Yeah.
how?
How we can identify like
Can we,
the
yeah. Can we
yeah.
generate any mirror image from this?
Let me see.
Yeah.
So I'm writing the second structure. I can compare the Fisher. Okay,
There is second
yeah, let
structure.
me see. Or yeah, sorry, I meant like oh yeah. Sorry, I meant like the one they put there already.
Mhm.
In Fisher. Um, are they mirror images?
Can we
I
firstly
don't.
check that NH2 and hydrogen in the same plane, while in this case NH2 and COH in same plane.
Yeah,
Okay.
yeah, yeah.
Yeah. So we can't check the mirror images in these
It's
cases.
not
So
a
what
mirror
we will
image. Yeah.
do, there is one last option, that is configuration R and S. Okay. We
Yeah.
will identify that R and S. Okay. So let's start with giving numbering, which is having first priority.
RNS. And the first for A, compound A. So that one, it would be nitrogen first, right?
Yeah.
A, sorry,
First
NH. Yeah.
nitrogen. Then second, this one,
CO. Yeah.
third, and fourth. So is it clockwise or anti-clockwise?
Mm, clockwise, right?
Yeah, clockwise. So
So R.
clockwise R. Do we need to change?
No.
Yes, why not? Because fourth
Wait.
group is on left hand and right hand side,
Wait.
na?
Wait. Where? Oh,
Okay.
sorry. I'm looking at the wrong structure. Yeah.
Okay.
Sorry.
So
Sorry.
S. Then here is the first, second, third, and fourth. And first, second, third. Okay. So is it clockwise or anti-clockwise? Anti-clockwise. What do you think? Is it clockwise or anti-clockwise?
Which sorry, for that one is anti.
Anti. Anti means
Yeah.
it is S. Okay.
Yeah.
Okay. So, and do we need to change? No, because fourth is in lower side. We don't need to change. So both compound having same configuration, S and S.
Yeah.
Is there an enantiomer? No. Is there diastereomers?
No.
No. Is there
No.
same compound? Yeah. So
Yes.
that's they are same compound. Okay.
Oh, okay.
Any doubt up to now? I will share this
What is
PDF with
what
you.
is the sorry, yeah, I was gonna ask
Yeah, you can ask.
like what does it mean? Like I understand how to do absolute configuration and like how it like but what does it really have to tell us about chirality and like the molecule itself? I don't know if that like in a
Like what
practical
is the
way.
use of
Yeah.
R and S configuration? You want to ask me?
Yeah, yeah, yeah.
So see, this is we are doing it as a theoretical practice. Sometime whenever we do our PhD and we do our masters. Okay, so in that case, we needs to we generate some molecules. We identify some molecules which are not researched up to now. Okay, so they are new molecules, and the molecule doesn't contain any sort of like they doesn't tell that I am C and here is COH present. Okay, so the structure we needs to identify the for that given organic compound, and for that we using different methods to identify the exact location of each atoms. Okay, so the stereochemistry is used to identify exact position of each atoms. R and S are
Mm.
used as a configuration. Okay, so if the compound is having NH2 on that side, like the exact position of NH2, let's suppose in the first structure, NH2 is in left hand side, hydrogen is in right hand side, like that. Okay, clockwise and anti-clockwise, how will they rotate the light? Is there chiral or not? So these are used in lab majorly. Okay,
I
is
see.
that
So it's like when you don't know what something could be, you would need something, a standardized method to actually determine
yeah,
it. That makes sense.
yes,
Okay.
right. Okay, and there is like 10 more questions, I think so. Wait, how many? Yeah, there is 10 to 15 questions more. I will share this PDF with you. Okay.
Okay.
And you'll do these questions. If you have any doubt, we will do in next class. Okay. Any doubt from today's class? Anything?
Wait, so um
Hmm.
the main difference between an achiral car center or no chiral carbon versus the molecule being chiral or
Yeah.
achiral
Yeah.
is
Yeah.
the main difference like is it just like whether there's the plane of symmetry or not, or I know there has to be four different groups but also like plane of symmetry, right?
Yeah.
If that makes sense.
Right.
Like if a molecule has one
Yes. Yes.
chiral carbon but then not another chiral carbon, that means the whole molecule is not chiral, right?
No, if there is only one chiral carbon are there, so the molecule will be chiral.
Oh, okay, okay.
Okay.
But if there's there okay, but there would still
But
so
but
okay,
there is
yeah.
if there is a plane of symmetry present, in
Hmm.
that case the whole molecule is not chiral. Okay, so firstly we will check the plane of symmetry. If there is any plane of symmetry present, so in that case it is achiral. If absent, then it will be chiral. Okay, and if the examiner will ask you that is there any chiral carbon over there, so in terms of carbon or in terms of a particular center, then in that case we will check the groups. While if they will ask you in in compared to molecule, so in that case we will check via the use of POS and COS. Okay, if it depends that is he or she asks related to molecule or related to the carbon. or any center. Do you understand?
Okay, but the definition of an achiral versus chiral carbon, it's like the difference is between how many groups there are that are
Yeah,
different, right?
yeah.
Okay, but in terms of the molecule itself, it has to do with the plane of symmetry,
Yes, yes, absolutely.
right? Okay. Um, okay, I think let me see if there's anything else. Let me see. Also, do I have to like focus a lot on optical activity or no? Is that
No,
important?
you don't need that. If a compound is a chiral, like if a whole molecule is a chiral, then it is optically active, and achiral means optically inactive. That's it. You only need these two
I
terms.
I keep forgetting what optically active means.
Optically, if a molecule is chiral, you can
Oh,
write
okay.
down with that. If a chiral, then it is optically active, and if achiral,
Um,
then it is optically inactive. But these are in terms of molecule, okay, not in terms of a center. You needs to know
okay,
this.
so like a chiral carbon because like it has the right amount of configuration for it to be active, right? In light or something.
Sorry, chiral, carbon or
Like
molecule?
a molecule, yeah.
Yeah, chiral molecules are always optically active. Always. Molecules.
Yeah, so like it has the right configuration, right? Like if you have four different
Yeah,
groups,
yeah, yeah,
then
yes.
that okay.
Mhm.
Um, and then also, how do you determine the center of symmetry? Is that like that
Center
important?
of symmetry is it is like a center of whole molecule for a complete molecule, any center, and from that center, each atom has its mirror image.
Oh, okay. So it's basically the center where the
Yeah.
plane of symmetry is going
Yes.
through, right?
Yeah.
Okay. Um, okay. Think that's all. And then I'll like let Sir know if anything comes up. Maybe he can pass along to you. But
Okay.
I
Yeah.
think that's it. Yeah. Sorry, I know I ask a lot of questions about like the theoretical stuff. I'm like very interested in chemistry. That's why. Like I'm thinking of
So
going
you
into
are.
like pharmacy.
Mm-hmm.
I was like really interested in pharmacy biochemistry because I realized there's so much about chemistry that's linked to biology. So it's really interesting to me.
Yes.
Yeah.
Yeah. Like chemistry is always like a very interesting topic for me also. If you ask some questions, it's like giving me that you are interested in these topic. That's why I'm like giving you more and more questions and like
Yeah, I
more
really
and
appreciate that. Yeah, it
yes,
whole yeah, I'm like I'm really interested in especially the organic chemistry. I'm interested in that
yeah.
because it
I'm
has to
also
do with like
doing yeah.
living things.
I'm also doing my PhD in organic chemistry, so I'm also very
Oh, oh, that's really cool. Maybe
yeah,
you can inspire me to learn more about the field and
yeah,
maybe go
sure.
into it or something. Yeah, that's really